So this is one of China's earliest domestic high-end AI GPUs. This is a dual GPU card. You can see the two GPUs here. This is the Huawei Atlas 300i. It technically has a combined 96 gigabytes of memory split across two groups of 48 gigabytes, one group per GPU. And this is not technically for sale in America, but we have one. We worked with Vincent from our AI GPU Black Market documentary to buy one and ship it to us. We paid $1,400 US. And just for comparison, by VRAM alone, NVIDIA's 96 gigabyte RTX Pro 6000 Blackwell is about $8,000. Now, this is not the performance of that card, but it is the VRAM capacity, and that makes it interesting. Huawei is not there yet. They have a lot of ground to gain to get anywhere close to NVIDIA, but this has become an interesting storyline. Today we're going to tear this apart. One of the problems we've run into is compatibility. We'll talk about that in a separate video. But the storyline that's developing is, if China and companies in China have limited access to high-end GPUs, then obviously they're going to try and make their own. This is not a high-end GPU by the standards of what is shipped in the global market from NVIDIA, but it is a potential threat eventually, depending on how it shapes up. And Huawei does have some state-backed funding that may push it further than you would see from a fully privately funded company. So it's a pretty interesting thing to look into. We are going to keep it purely technical today. If you want some of the interesting geopolitics behind it, you can check out our Black Market GPU smuggling documentary. But for this one, we're going to do the teardown. And as far as the testing and the benchmarks, that's something we're working on. But we'll talk about some problems with that in a minute.
在那之前，这个影片由 Hyde 为你带来 Hyde 的 Y70 Touch Infinite 电脑机壳。最近推出了多种以珍珠奶茶为灵感的配色和设计，比如说芋头、草莓、蓝莓，然后其他的风格。我们之前测试Hyde的 Y70，注意到它的做工优良，也竞争力很不错。现在新的 Y70 Touch Infinite 有比较大的 IPS 触控萤幕，你可以用它来听音乐，看一些影片，看一看今天的天气等等。如果你想了解更多资讯，可以点击下面说明栏的链接，回到正片了。
All right, so the problem we're running into with this, it doesn't work in our motherboards. It's really pretty simple. They don't work. So we've tried this in a couple boards. We've shipped one to Wendell. We bought two. One is for him, and he's also messing around with it. But we've had some compatibility issues. Technically, I think we can force it to work, but on paper, this is supported by a very specific set of Huawei servers. These are so new that they don't just work when you plug them in. So this is challenge number one with contending with AMD, Intel, or NVIDIA in the space. Now, Huawei has plenty of money behind it and sort of a government behind it, so it's possible they get there. As of right now, this instant, there are some compatibility challenges that you wouldn't normally face.
Interestingly, the United States has also now involved itself in our silicon production via its 10% stake in Intel, so this does seem to just be kind of the direction of the world right now with high-end silicon. A couple interesting things with this card. First of all, its performance is very low right now. The card is using LPDDR4X, and it advertises a memory bandwidth of 408 gigabytes per second. However, that's card-wide, which means the actual memory bandwidth per GPU is just 204 gigabytes per second. Likewise, the PCIe would be split. You'd need bifurcation for it, although it's definitely not fast enough for that to matter. And RTX 6000 Pro advertises nearly 1.8 terabytes per second memory bandwidth, although that card is also about 6 times what we paid for this. Huawei's dual GPU here also has limited software support in addition to hardware support. NVIDIA obviously is superior, just to make sure no one gets that mixed up, but that's not unexpected. Huawei is also attempting to support its domestic market since the US is restricting GPU exports to China, including the 6000 Pro Blackwell, and so it's not competing globally in the same way. It's not competitive now, and we'll show that in benchmarks in a future piece, but you also really have to remember that they need to stand before they can walk at Huawei. And just like we talked about with our Huawei CPU reviews a couple years ago, it's easy to kind of point and laugh at an underperforming piece of silicon, but from a company that's new to it, we do think it'd be foolish to write off uncompetitive early attempts at silicon, especially keeping in mind that right now, there's a lot of political motivation to make good GPUs by both the US and China, so things can move on an accelerated timeline for both countries. Anyway, point is, we're looking at the early stages. Don't expect this to be a killer of any of the existing companies' silicon right now, but it's shipping to different market conditions domestically, and they got to start somewhere. We'll just see if it goes anywhere. It may not, who knows, just depends.
Now there is a solution to this problem so that we can benchmark it. We bought a Huawei server. It's on the way to us. We bought the Atlas 800 inference server, which is model 3000, and it has two Kunpeng 920 CPUs. So these are 32 core processors. These are also domestic to China. It has two 900 watt redundant power supplies. It's got some swappable fans. And we basically bought a used one of those servers to plug this into when it gets here. And we can force it to work in a Threadripper board. I would rather see it work in something that is officially supported, that Huawei says is officially supported, so we can actually see the performance. This is intended to receive forced airflow from a server chassis, so it does not have its own fan. You may be able to see down there, there's no fans, there's no blower in there, it's just a board. And so this sockets like that in a server, and then it's force-fed air like would happen in basically any server anywhere, and then it's mounted in a rack, kind of like this server rack here, except instead of decorations with waifu video cards and a 7850 from probably, I don't know, over a decade ago, it would have a server in it. The rest of the card on the back, you can see what I think are probably going to be the two GPUs, and then there's going to be all the memory as well. As far as PCIe, so this is PCIe Gen 4 support by 16. Because it's dual GPU, it's really important that it's in a by 16 slot so that each can get by 8. And then they would need to support bifurcation as well of some kind in order to run both GPUs on one board. These are some cables that came with it, so it's kind of interesting as well, where if we look at the end of the card, it has technically an 8-pin, but that is much smaller than your typical PCIe or EPS 1208 pin. A lot of server GPUs use EPS 1208 pins instead. This comes with, I don't remember if that's a micro or a mini fit adapter. Feel free to let me know in the comments. I'd have to look it up. But this is just a smaller 8-pin connector, basically, and then they ship with these two different adapters for it. So that's how you would adapt it to a power supply. Otherwise, the rest of this is pretty normal as a video card, so we can just start taking it apart. It's going to be really simple, I think. I see a couple screws on the back that are just Phillips. All right, so we're working on our anti-static mod mat. You can buy these on store.gamersnexus.net. We launched these back around 2017 or so, and this version has a screw tracking diagram with an outline of various GPUs. That's going to help me keep track of where things go, just because I've never taken apart a Huawei video card before. So this is kind of a weird one for us. We'll see if they become more common, but it'll be interesting to learn about what appears to be an emerging market in China, especially as there's all these back and forth export controls between both countries now. China restricting H20 sales to some companies, the US restricting and unrestricting NVIDIA GPU sales, depending on what week it is and which card it is. So this is probably something we're going to see more of. But all right, so I've loosened every screw just a little bit first, just in case any of these are spring retained on the other side. I'm not sure how they assemble these yet. First time I've taken one apart. And these are just Phillips 1. All right, easy enough. So we'll track this up here at the top of the card. Start with the screws that are clearly just for the plate and whatever heatsink there might be. Okay, anything loose yet? Not yet. All right, we're going to take these out now. I feel like I'm playing like with the controller set to inverted because the mat is upside down for the camera, which means that goes there. Yep, all right. All right, inverted mode assembly, disassembly. Sorry, I switched the two words because we're in inverted mode. Is now complete. What's gonna come apart? Oh, everything. Literally all of it will come apart. That's the answer. There's a screw in the back here, so we're gonna get rid of that. That's under a piece of tape, I'm not sure. I'm sure we had a good reason to cover that in testing. Oh, I know why this was. This was because it didn't fit. It didn't quite fit in the slot, PCIe slot, without loosening it to give it some play. It was slightly misaligned. Okay, well, this is gonna be the easiest teardown on earth, apparently. Wow, that's interesting. I'm really not looking forward to dealing with this. Shit, all right. We've worked with these before. These appear to be graphite pads.
All right, so pulling up our old content here, the Radeon 7 is the one I was thinking of. That used a Hitachi HM03 graphite thermal pad. Officially, not that this means a whole lot, but the thermal conductivity is between 40 watts per meter Kelvin and 90 watts per meter Kelvin, with the effective range closer to 25 to 45. That's according to one of our old reviews that we wrote. Now, that pad is orientation specific. We're not exactly sure what is being used on this. It's not the same consistency as the Hitachi pad, but it's a similar concept. It would be maybe a better gap filler if it's uneven.
These pads worked okay back then for AMD. The biggest thing they did was solve for height differences in the HBM, the silicon die, and their assembly or packaging solution, where we had uncovered a number of pressure differences between the HBM and the die on those AMD era GPUs. And this helped to account for that because it would conform to the surfaces a little bit better and fill larger gaps than paste would, while being very high thermal conductivity. But they kind of sucked in a lot of other ways, namely reassembly. Anyway, so they're using that. This is an IHS. I almost want to delid this, but we need to test it before we destroy it. So that's going to be an actual integrated heat spreader on a GPU, which has been a thing in the past. But in the consumer world, not for a long time. So if you look down there, you can see the substrate underneath, and then what appears to be a nickel-plated copper integrated heat spreader. So this is very different from what we would see from an NVIDIA, AMD, or Intel product today, where they would just use exposed silicon. The reasoning for that is pretty simple. With exposed silicon, you end up with the silicon, the hottest part, directly contacting the cooling solution. You really want as little as possible between the silicon and the heatsink. Now, on a CPU, there is an integrated heat spreader. That helps with things like providing some structural support, for example, against high mounting pressures that could crack the die. It helps with providing a leveler surface. It reduces RMA issues. It can make packaging a little easier because they don't have to be as perfectly precise with the tolerances on the silicon height if there's multiple chiplets, for example. There's a lot of reasons to do both, but in GPU world, it's mostly gone to direct die cooling, and that is the most effective. It's the fewest interfaces in between the silicon and the heatsink. So this is kind of a throwback for me. I think there's some enterprise solutions that still do this, but as far as the memory, you can see this is very small, these memory modules. They're not what we would typically see for VRAM in a GPU. Actually, we've got an example over here. So on the wall here, we have a kind of special MSI Lightning. This variation never shipped. I think they made 50 of them where it's an expanded VRAM. But anyway, the thing that matters, you can see the VRAM pads here. So these are BGA ball grid array pads where there's no memory or GPU soldered. You can see those are a little bigger. Same here up on this Kunpeng model. That's just a blank PCB at the top. So these are just the pads where that is significantly wider than what we're seeing on this Huawei card. So Huawei is using, that means LP DDR. I believe this is going to be 4X maybe. Let's double check. Yeah, so it's ECC LP DDR4X. That's what they have on here. 408 gigabyte per second card wide memory bandwidth. And LP DDR4X, I haven't seen in a while on a consumer device, especially moved over to more modern memory choices. But that would be would have been found in a laptop or some handheld solutions, basically. You wouldn't normally find it in a discrete video card like this. I would guess it has to do with maybe cost and density or something, or supplier. We could look at who their supplier is if it's. Oh, that's interesting actually. So if we get in closer here on the memory, you can see it's got this almost like darker coating here. Where that hardened, it is. I don't know if that's intended to close a gap that was unintended, or if that's just how this memory looks. There's almost there's a bumpier surface that protrudes a little bit from the base of the LPDDR. So that's kind of interesting. And there's all of them in this bottom corner are level. So anyway, that's direct contact via a thermal pad that doesn't cover the whole memory module, which we have found that matters in our thermal testing in the past where we've like wired up probes to memory modules. But they're direct contact here to what looks to be an aluminum heatsink right there and on all the other sides. So we've got 4 kind of groups totaling the 96 gigabytes of memory. As for the rest, VRAM, so voltage regulator module here, it's going to be for this GPU. That looks like probably memory VRM. We'll look at that. That's probably memory VRM. And then this is more of the VRM over here. So we'll map it out and see where vCore is. You can see some unused blank pads for connectors out here. And then on the other side, below the power connector, 2 more unused pads for connectors. Okay, so this is pretty interesting. These are just for comparison. This is from an NVIDIA RTX Pro 6000 Blackwell GPU. So that's the PCB from our teardown of that. This is from an NVIDIA prototype that never shipped, that we took apart mostly for its cooling solution, but this was technically that one was a 4090, but it was like prepping for a Titan, which Roman has taken apart. So the reason I pull these out is if you just look at the density, I mean, NVIDIA, like as much as they do stuff that I think is like awful and anti-consumer, they do get credit for really crazy engineering. And if you just look at the density of this PCB from NVIDIA, it is obscene how dense it is. I mean, these are their inductors, right? So they're using a lot of more expensive tiny inductors, a lot of MLCCs all around the board that are smaller. The density, I mean, on both sides is crazy. They've really packed this board in. They've done an excellent job at it. And this is an axial fan-cooled workstation card, not a server card. But the reason they've done this is so they can do blow-through on both sides of the PCB with the fans to not obstruct it with the PCB. So they get better cooling. And then you see the exposed die there too, compared to what Huawei is doing with the IHS. This is also a gargantuan die, this Blackwell solution, and even just the substrate with this metal plate on it, it's huge. So there's a big difference here between the two companies, where Huawei is still more in the early stages. Wouldn't say I mean, they don't have CUDA either, so not really a direct competitor yet, but who knows where it'll go. All right, a couple small things. I mean, there's a shunt resistor over here. I don't know that piece right there. I don't know if it works the same way, if we could use that to piggyback another shunt on it and trick it into pulling more power, but this is a 150 watt board natively, and then it's got a fuse here, so that's a fuse. Normally these don't blow fast enough to protect the circuit that it's attached to, but they would help with diagnosis of an issue, according to Buildzoid, who we've worked with on this stuff in the past. All right, so we'll come back to that for some VRM inspection. Looking at the rest of the cooler, let's see how to pull these apart. Is it slide? Is it screws? All right, I'd really like to get this out. You have any dentist tools, Andrew?
I feel like I saw a lot by the soldering table.
Yeah. I feel like I need safety glasses. I don't think this is the best way to do this, but I think it's gonna work. Nope. If anyone from Huawei, like on the mechanical engineering team is watching this right now, then I just want to say, 太不好意思了，我就是不知道怎么做，睁一只眼闭一只眼，对吧? Okay, all right, I'll have to bend that clip back, but all right. So let's do this. So for now, we're gonna pause there while I figure out if there's a way to remove this without just unbending it all on the edges. That's pretty cool. You thought I couldn't do it, huh? I was prying at this earlier, but there was this like divot I'd noticed, and I thought maybe it was a button or something, like a release, but it isn't. What it is, though, is they punched it in. So they punched that hole in, and the metal sticks in on the inside, which is going to be really hard to see on camera. And so this small, shiny piece, I saw when I was about to give up on it, and realized if I just peeled back at the opposing edge that we hadn't already peeled back, then it would get that bump over the metal clip. So I just got to get the bump over the edge, and then it releases it. Sick. All right. It's metal. That appears to be aluminum. Not really connected to anything, so it's not going to do a lot. If it does contact these at all, though, it'll pull some heat. It's just most of the cooling is going to happen through the fin stack. So let's take a look at this. This is the cooling solution. They have two flat-ish heat pipes. These would probably be called a marketing 10. It's 8.8. So they're roughly 8 millimeter heat pipes. They're flat. I guess you could call it probably a 10. That was flattened. I don't know. I don't know what marketing would round up. But anyway, two 8 mils. Those are running through both of them, right across the IHS. And then very simple aluminum fin stack with the L shape. Now, on a lot of consumer cards, you'll see the top of the fin stack is open. That's to allow air in and out. On these server boards, the reason, well, and some consumer boards, but the reason they'll close them off with the L shape like this is simply so that the air can't get out through the top. They want to force it all the way through with as much pressure as they can to just clear the fin stack and pull the heat out. So that's intentional. These are not particularly dense. By the time the air gets to the board, plus with the obstructions in the way at the inlet, it probably helps to not have too much resistance as long as they're able to cool the 150 watts. This is going to require an enormous amount of airflow, though, to keep cool, which in a server should be abundant, so that shouldn't really be too much of a problem. But that's an aluminum fin stack. I would assume these look to me, wow, those are ultra thin, actually. Wow. Check that out. That is a really thin heat pipe. That's not going to do a whole lot. But so those are like laptop style 8s is what those are. Very thin heat pipes. So those look to be nickel-plated copper. And then they've got these. This is actually kind of interesting. You can see the witness mark here, this blue marker. So they are a little bit out of alignment on some of these, I guess. But they witness marked the base and the screw, which will help them know how much to tension it, I guess. That, to me, suggests this is hand-assembled, which isn't abnormal for a video card. Okay, so for memory, we've got 6 modules per GPU so far. That density is not going to be enough. So then if we pull this back plate, you can see there's 6 more aluminum contact patches integrated with the aluminum back plate. That's really not a whole lot of cooling, but these are probably fairly low power. We've got some thermal pads just on the center of the memory modules, which is never ideal, but again, probably sufficient here. Generally speaking, covering the entire pad, like you see on this NVIDIA board, that actually does have an impact, and it does improve performance. So they're just smashing down a smaller pad, like a piece of gum, basically, on the back. So that means each module is going to be a 4 gigabyte module. There's 24 modules total. It's 96 gigabytes of VRAM. And then if we look again at the Blackwell card, that's 96 gigabytes. This one is using a more modern GDDR7. It has, let's see, what is this? 5, 10, 14, 16, so it's going to be 32. At 3 gigabytes each to be 96, and this is going to be fewer total modules at a higher density, but with worse memory, lower bandwidth, and that gets them to 96 here. So yeah, if these are hand assembled, I mean, that is how most video card coolers are done. All the components for the PCB tend to be pick and place with the exception of some heat sinks sometimes, some inductors sometimes. It's mostly pick and place machines. And then the heat sinks tend to be done by hand assembly in an assembly line. Each person does one set of screws, for example, one type of screw. So that looks to be what's happened here. That's not abnormal. And otherwise, it's a pretty simple solution. I mean, it's just 2 heat pipes and 2 aluminum sinks. Even this looks to me to be aluminum, not nickel-plated copper. So they're really going cheap on these heatsink solutions. This is it's It's not quite the caliber you would see in a lot of other cards, especially at $1,400. And just to be fair, it was listed for like $3,000 on eBay, but buying it directly through our source was a little cheaper. I'm not sure what the official retail price is, but that was our markup. So anyway, next step is probably going to be the actual testing in a server, and so we've got that on the way. We could try and run it in our Threadripper box. Wendell is experimenting with that. It's not officially supported, and we don't want to make a judgment on it based on something that's not supported for. So that's another excuse for us to try out these CPUs from China as well, the Kunpeng 920s or whatever they're, the dual 2x32 core CPUs in that server. So that's it for this one. Thanks for watching. We'll have more on this as soon as we get the server in. It might be a couple weeks or more, depending on how long it takes us to figure out how to get the workloads to run. Those servers have very limited NVIDIA and AMD support as well. So the list of officially supported cards on those servers, I think it's like 6 different models, and a few of those are NVIDIA, and so we'll test those. But it's going to be a pretty limited roundup due to that. It'll be our first sort of look at China's attempt at a piece of GPU silicon, though, by their definition of it. And yeah, we'll have more on this. But subscribe for more as always. Go to store.gamersnexus.net or patreon.com/gamersnexus to help us out directly. And if you want to see more of this type of stuff, check out our AI GPU black market video. We'll see you all next time.